Okay, so what I'm doing is the radical equation. As you can see, right here is the regular equation. Okay, and now what I did, well, right here it's optional, but what I do is I rearrange the problem to make it easier for myself. But okay, so step 1 is that you subtract the 3 since it's the inverse of the addition, and inverse is the opposite of what's being done. So if it's like multiplication, it's division, or division and multiplication. It's just the inverse. So I did the inverse of addition, which is subtraction, and subtracted the 3 from the 3 to get it on this side, so I could cancel it out over here. So that's why there's an x through it. So now I have 18x minus 18 under the radical equals to 3x minus 3. And I have the squared right here because I wanted to take the inverse of the radical, which is squared. So in order to cancel out the radical, I have to square it, which is what I did right here, which is why it's canceled out. But what you do to one side, you have to do to the other side, which is why this is in parentheses squared. So now that I squared this, I used FOIL right here. What I did was FOIL. That's how I got this problem. Oh wait. So then the next step is 18x minus 18, and it's not under a radical because I canceled it out, equals 9x squared minus 18x plus 9, which I got from this when I FOIL it. So 3x minus 3. 3x minus 3 is squared. So you FOIL and do all this, and then that leaves you with 9x squared minus 18x plus 9. Now what you do is you add the 18 to this side minus the 18x to this side, and that leaves you with 9x squared minus 36x minus 27 equals 0. Since we carried all of this over here to this side, this leaves us with nothing, which is 0. But we can combine this side with this side because they are like terms. The x and the x, the constant and the constant can be combined because of like terms. But here, and then after this step is this 9 parentheses x squared minus 4x minus 3 equals 0. What we did here is we factor out a 9, we factor out a 9 out of 27 because 3 times 9 equals 27. We factored out a 4. Well, we factored out a 9 and got a 4 because 9 times 4 equals 36. And we factored out a 9 because 9 times 1 equals 9. After we do this, it's just like a quadratic, and we could set our two binomials, and this is where the box method comes in, where it's the x squared minus 3, and it will be x minus 1, x minus 3, because those are the two digits that only equals 3 because it's a prime number. So if you add this all up, x1 minus x minus negative 1x, negative 3x, x squared, negative 3x plus negative 1x equals 4x, negative 3. That is exactly what we have here. And then now we have the two, as you can see, the two binomials is on top and bottom, I mean on the side. So then once we do that, we find out what x equals, and we do two separate equations, find out what x equals, which is x equals 3 and x equals 1. X minus 3, as you could solve as a regular problem, plus 3, as I did, plus 3. Okay, that cancels out. It's just x left with, and then 0 plus 3 equals 3. X equals 3. Same on here. X equals 1.